Hi, hello friends, welcome to our channel Study of Mathematics. Next, we will solve the next problem in the same exercise 3b, section 3. Problem number is 3. The problem is if a equal to 3 minus 4, 1 minus 1, then show that a power n equal to 1 plus 2n minus 4n n 1 minus 2n for any integer n greater than or equal to 1 by using mathematical induction. This is our given problem. In this problem, we have to show a power n value by using mathematical induction. We already know the procedure of mathematical induction. Then, by using that procedure, we can solve the solution. Solution first write in the given matrix. Given matrix A equal to 3 minus 4 1 minus 1. This is the matrix A. By using the mathematical induction, by using the mathematical induction procedure, mathematical induction, first we consider P of n value. First we consider P of n. Consider P of n such that P of n is a power n. A power n is equal to 1 plus 2n minus 4n n 1 minus 2n. This is a power n value. First we can prove, we can show n is P of n is true for n equal to 1. For that, if n equal to 1, then P of 1 such that a power n means 1 equal to, we can substitute n with 1, 1 plus 2 into 1 minus 4 into 1, 1 minus 2 into 1. That is equal to 1 plus 2 minus 4, 1 minus 2. That is a power 1 is a. That is a equal to 3 minus 4, 1 minus 1. This is our given problem matrix. A matrix is equal. Then we can easily know that P of n is true for n equal to 1. Then we can consider or assume that P of n is true for n equal to k. That is, suppose that the given condition, statement P of n is true for n equal to k. That is k greater than or equal to 1. That is P of k such that a power k equal to 1 plus 2k minus 4k k 1 minus 2k. This is our assumption value. Next we can prove P of n is true for n equal to k plus 1. For that, consider P of k plus 1 such that a power k plus 1. A power k plus 1 nothing but a power k into k. That is equal to a power k value is 1 plus 2k minus 4k k 1 minus 2k into a value 3 minus 4 1 minus 1. After we can multiply the two matrices. That is equal to first row with first column 3 into 1 plus 2k plus into minus 4k into 1 4k minus 4 into 1 plus 2k, minus into minus plus 4k, 3k plus 1 minus 2k, minus 4k minus of 1 minus 2k. Then after multiplication, that is equal to, and again calculation, 3 into 1 plus 2k, that means 3 plus 6k minus 4k, minus 4 minus 8k plus 4k, 3k plus 1 minus 2k, minus 4k minus 1 plus 2k, that is equal to 3 plus 2k, and minus 4 minus 4k, k plus 1. Next here minus 2k minus 1, sorry, that is equal to, for our convenient, we can write the each element into 3 can be written as 1 plus 2 plus 2k. Here take minus 4 as common into k plus 1 or 1 plus k. Here k plus 1 only. Here we can add and subtract 1. That means minus 2k minus 1 plus 1 minus 1. That is equal to 1 plus, here take 2 as common, 2 into k plus 1 minus 4 into k plus 1, k plus 1. Here minus 2k minus 2 plus 1. That is equal to, then here 1 plus 2 into k plus 1 minus 4 into k plus 1, k plus 1. Here also take minus 2 as common, k plus 1 plus 1. This is our a power k plus 1 matrix. By compare with this with P of n, we can easily know if substitute n equal to k plus 1, then this matrix can formed. Then we can write that P of n is true for n equal to k plus 1. Hence, by the principle of mathematical induction, method, the given statement P of n is true for any integer, n greater than or equal to 1. This is our third problem solution. Next, we will go to fourth problem in the same section. Next, fourth problem is give examples of two square matrices A and B of the same order for which AB equal to 0 but BA is not equal to 0. This is our given problem. In this problem, we can only write two matrices A and B for our assumption, because the AB matrices are taken. AB matrices ఏ విధంగా ఉండాలంటే AB equal to 0 కావాలి, కానీ BA is not equal to 0 కావాలి. If the matrices A and B are as follows, but AB equal to 0 but BA not equal to 0, then that example values are solution. Let us take the matrices for our assumptions, or examples are our assumptions. Matrices A equal to, this is one of the example. There are so many matrices like this. We have in this problem we can take only 2 by 2 matrices. A matrix is 1 0 1 0. B matrix, let it be 0 0 1 1, or the two square matrices are the two square matrices of the same order, two for which AB equal to 0 but BA is not equal to 0. These are the two examples. If you can only check AB equal to 0, by multiplying these two matrices, we can easily have the AB value 0 but BA is not equal to 0. This is the examples. For our understanding, we can multiply AB equal to 1 0 1 0 and B value 0 0 1 1, that is equal to multiplication 0 plus 0, 0 plus 0, 0 plus 0, 0 plus 0, that is 0 0 0 0, that is O. AB equal to. Next, BA, similarly BA is 0 0 1 1, 1 0 1 0, that is equal to first row first column 0 plus 0, first row second column same 0 plus 0, second row first column 1 plus 1, second row 0 plus 0, that is equal to 0 0 1 0, 2 0. This is not equal to 0.
Thanks for watching our video. For more videos, please like, share, subscribe to our channel and hit the bell icon.